Okay, the following is a video for 10.5 notes. This is about tangent lines. Tangent lines is something that is a very, very big concept when it comes to calculus. A lot of what we do is talk about tangent lines. And a tangent means that it intersects a curve only once, okay? And so that's what's happening down here. And we have a circle, and we have some unique properties about tangent lines to circles. But I have this circle here, and the weird thing is that the circle touches this blue line at this one point. So I'm going to call this point A, all right? I'm going to call this point B, so the center of the circle, and this point C. And we'll call this point D over here. Now, the one real-world thing that you guys see every day, something that you don't really realize that you're constantly using tangent lines, or that something that you use always creates a tangent line. But if you think of this as a tire on a car or a bicycle or some sort of wheel, some sort of tire, and this is the road, okay? And you want to see where this makes contact with the road. So where the tire makes contact with the road, we call that a tangent point, okay? So, you could think of the tires are the things on your car that make contact with the road. The car is the thing on the road that takes you back to your abode. And bummed is what you are when you go out to your car and it's been towed. But I always think about that when I'm driving in a car. That every time, at any point, whenever my tire is hitting the ground or the road, then it's hitting at that point only once. Okay. So remember, the tires are the things on your car that make contact with the road, and that happens just at one point. Okay, so let's kind of talk about the mathematical principles here, and let's kind of look at some unique things that we can find about tangent lines to circles. So the one thing that I've got here is that I've actually gone ahead and measured the length of AD. So the distance from point A to point D ends up being 5.4 centimeters. Okay, and I encourage you guys to actually sit down and measure that length. And then let's go ahead and let's take point C and point D and connect those with a line. So if you get a straight edge and then connect that point C with point D. All right. And so what the unique thing that's happening here is that if I have this tangent line, okay, so point C is a tangent line, or I'm sorry, point C is a tangent point to line CD, to circle B. What I notice is that this segment for AD is congruent to segment CD, and segment CD is also 5.4 centimeters. Okay, so I encourage you to do that if you just line up point C and point D and connect both of those points. Now, the other unique thing about this is that the intersection of segment AB and AD creates a perpendicular angle, okay, or a perpendicular line, so a 90-degree angle. Okay, and the same thing can be said here at point C. So segment BC is perpendicular to segment CD. All right, so I'm going to write that. So let's write that segment CD is 5.4 centimeters. And then let's write that segment AD is also 5.4 centimeters. So what we find out is that if we have two tangent lines that intersect at a point, then we know that those tangent lines are actually congruent if they intersect. So we can say that AD is congruent to CD. All right. Now, the other thing I can say is that the tangent line and the radius that connects the center of the circle to the tangent point is perpendicular to the tangent line. Okay, so I can say that AB segment AB is perpendicular to segment AD. Okay, I can also say that segment CB is perpendicular to segment CD. All right, so these are just some things that we can say about tangent lines. If we know that we have a circle and it contains tangent lines to that circle, and if they intersect, then I know that these two segments are congruent. So let's go through some practice problems. Let's see what we can do here. So the first couple problems that we've got says, determine whether each segment is tangent to the given circle. Justify your answer. So we want to know if HI is tangent to circle G. Well, if it is tangent, then I know that the radius here and the tangent line make a right angle. So thus creating a right triangle. And right triangles have that same property that our dear friend Pythagoras is so well known for, and that's if I take 9 squared plus 40 squared, then it's going to give me the hypotenuse squared. Okay? And so if you evaluate 9 squared plus 40 squared, it actually ends up giving you 1,681. And if I square 41, I actually get the same value, okay, which is pretty cool. And so because this is a true statement, then I can conclude that HI is tangent to circle G, okay? And so I just want to use the Pythagorean theorem. So if the Pythagorean theorem verifies itself and I get that one side of the equation is equal to the other, and it's a true statement, then I know that HI is tangent, okay? So let's apply the same thing over here for number 2. If this is tangent, then this is a right angle, okay? So let's see. If I take 4 squared plus 12 squared, that should give me 13 squared. So if I take 4 squared and 12 squared, that's going to end up giving me 160. And if I take 13 squared, that's going to give me 169, okay? And this is a false statement, okay? 160 is not equal to 169, okay? It's not true. So because it's not true, then no. We say no. AB is not tangent to circle C, okay? So we just want to use Pythagorean theorem to verify that, all right? Now, the other thing that we can do here is we get these problems like this, where it says, all right, we've given you the scenario, now solve for x. Now, what we can assume is that PW is tangent to circle R, and we can assume that QW is also tangent to circle R. So because both of these lines are tangent and they intersect at point W, then I know that PW is congruent to QW. So I'm going to write that PW is congruent to QW, all right? So I can just set 3x minus 6 equal to x plus 10. Okay, and I can just solve for x from here. So if I subtract x from both sides, then I get that 2x minus 6 is equal to 10. Now if I add 6 to both sides, then I get that 2x is equal to 16, divide by 2, and I get x is equal to 8. All right. So given a scenario like that, we just know that the tangent lines are congruent if they intersect at a common point. All right. Now over here, if we assume that FG is tangent to circle E at point F, then I know that this is a right angle. And I know that if I have a right triangle, then my dear friend Pythagoras, his theorem holds true. So I can say that x squared plus 8 squared is equal to 17 squared. Okay, so let's solve for x here. So I'm going to evaluate this and get x squared plus 64 is equal to 17 squared is 289. Okay, if I subtract by 64 on both sides, then I end up getting that x squared is equal to, oh, what is that, 225? Okay, and if I take the square root of both sides, then I end up getting that x is equal to 15. So, you know, just using the pictures, I can set up an equation and solve for x. So that's the expectation. The next thing we have is something a little bit different. Now, when we have a circle that, and we call this, I believe it's circumscribed, where a circle is inside and that we create a polygon out of tangent lines, then what we can do is actually find missing lengths and find the perimeter of these polygons, okay? So what I know is that if all these lines are, if all of these lines are tangent, then I know that these segments are congruent. I know that these segments are congruent, okay? And I also know that these segments are congruent, okay? So I know that this length over here is going to be 4. I know that this length here is going to be 13. And I know that this length is 9 and this length is 9. So first of all, it wants me to solve for x. Let me do that. And I know that 9 is equal to 2x. So if I divide by 2 and divide by 2, I get that x is equal to 9 halves, which is 4.5. Okay, so that's the first thing. Now I can just solve, and now I just want to find the perimeter. Okay, so the perimeter would just be, now I have 9 and 9, 13 and 13, 4 and 4. So I can take 9 plus 9 plus 4 plus 4 plus 13 plus 13. Okay, now if I'm doing repeated addition, that means I can just multiply. So I can take 2 times 9 plus 2 times 4 plus 2 times 13. Okay, and I get that my perimeter is 18 plus 8 plus 26. And if I add those numbers up, I'm going to get 52. And since there's no label on this, I'm going to call it units. Okay, and that's my perimeter. All right, I'm going to do the same thing over here. This one's actually a lot easier. Now, what they give us in this scenario is that if these are all tangent, then if this is 13, if HR is 13, I know that HS is 13. Okay, I know this is congruent to that. Now over here, if I have another tangent line that's 13, then this length is 13. So x is equal to 13. All right, one last thing. All right, that's good. So now, I also know that if this is 5, then this is 5. So these are congruent, and this is 5. All right? Oh, look, I have this as 5, so then this also must be 5. So I have a four-sided figure here, and the total length of each of these is 5 plus 13, 5 and 13, 5 and 13, 5 and 13. So what I can do is I know that each of those lengths is 18, so this entire length of each of those is 18 units. All right, so I can take my perimeter is just going to be 4 times 18. All right, and if I multiply those, I get 72 units. All right, so tangent line is some pretty cool stuff. If you end up making it to calculus, you will talk about tangent lines for a very long time. But I do want to introduce it and some of the properties that we have with circles. So hope you enjoyed the video. And remember, guys, the tires are the things on your car that make contact with the road. All right? The car is the thing on the road that takes you back to your abode. Bummed is what you are when you go out to your car and it's been towed. Okay? Tangent lines. Really fun stuff.